This is the part 2 of our first section on complex numbers. So this part we're going to focus on what are equal complex numbers and how to add and subtract complex numbers. It won't take too long. We already know what complex numbers are. They're numbers of the form x plus iy. Two imaginary or complex numbers are equal if the real parts of these numbers are equal and if the imaginary parts of these numbers or the coefficient in front of the I are equal. So if we have z1 and z2 that are complex numbers, they're equal if the real part and the imaginary parts are the same. For instance, if I have the number 3 plus 4i, this would be equal to a complex number 3 plus 2 squared I, or it's even equal to the complex number z3 equals 3 plus root 16i, because all of these basically are 3 plus 4i. Sometimes an example will ask you, if you have, say, z1 that looks like, say, 3 plus 4i, and if you have another number z2, which equals x plus, let's just say, 1 plus y in brackets I. The question might ask you to figure out what your unknowns are. So what x and y are if z1 and z2 are equal. All you have to do in this question is equate the real parts of each complex number and equate the imaginary parts of each complex number. So for my real part of z1, I have 3. The real part of z2 is x. These two have to equal each other for the numbers to be equal. So x would have to be equal to 3. Again, the imaginary parts of z1 have to be equal to the imaginary parts of z2. z1 is positive 4. z2 is positive 1 plus y. That means 4 has to equal 1 plus y, or y has to equal 3. And that makes sense because both numbers should look something like 3 plus 4i. How do we add and subtract complex numbers? The last part here. Addition and subtraction of complex numbers follows the same algebraic and like term properties seen in previous years in algebra. That just means the reals will be like terms with the reals and the imaginaries like terms with the imaginaries. And that's what I would like you to think. For instance, if you have a complex number z1 equals a plus bi, where a and b are just real numbers, and z2 equals, say, c plus di, again, c and d are just real numbers. To add them together, this is what we do. Firstly, write both the numbers out and put a plus sign in the middle. You can put brackets in so you just keep them separate for now. Then we will get rid of the brackets. And we need to identify the real parts of each numbers and the imaginary parts of each numbers. So A and C are both just real constants. BI and DI will go together because they're the imaginary sections of the numbers. Then we add. So real parts, I'll have A plus C. Then I have a plus BI plus DI for my imaginary parts. I'm going to group the real parts together, A plus C. Then I'm going to take the I out the front, okay? And I'll have B plus D in the bracket. So the I I'm taking out just as a common factor. And you can either write the I in front of that final bracket or after the final bracket if you prefer. Let's have a go at the first example. We're going to simplify z1 plus z2 Well, Z1 is 2 plus 3i, and Z2 is 1 plus I. So we're going to add these two complex numbers together. Again, you can get rid of the brackets straight away. And then you're going to identify the real parts and the complex parts and add them together like terms. So we'll have 2 plus 1. They're my real parts added together. And I have this positive 3i plus a positive I for my imaginary parts added together. Let's see what you come up with. So 2 plus 1, I know that that's 3 for my real parts. And I also know for my imaginary parts, 3i plus 1i, I can take the I at the front. And in the bracket, I'll just have 3 plus 1. And then I'll just simplify. So I'll really have Z1 plus Z2 is equal to 3 plus 4i. And again, the I can be in front or behind the 4, it doesn't matter. The same process applies for subtracting complex numbers. The only difference is you have to be careful of the minus sign in the middle. So let's do an example where A, B, C, and D are arbitrary real numbers. If I have Z1 minus Z2, I'll have A plus BI minus in brackets C plus DI. So here the bracket is important because you're going to expand, bringing that minus sign through the second bracket like you normally would. We will have A plus BI minus C minus DI. So the expansion is the same. Now what we do, again, group the real parts together. Don't forget your signs here. And then group the imaginary parts together. The reals will have A minus C. And the imaginaries, I have a positive BI, so plus BI. Then I have a negative DI. I like to put a brackets around my real parts. And then I like to factor out the I. And I'll have B minus D within my bracket. Let's simplify. 2 plus 3i minus, in brackets, 1 minus I. So that's my Z1 in front and my Z2 after the minus sign. First thing you do is you expand. 2 plus 3i minus 1, and then minus times minus I, that will just be positive I. Okay, group the reals together, and then group the imaginaries together. 2 minus 1, that's pretty nice. Then I have plus 3i plus I. Lastly, tidy it up. So 2 minus 1, hopefully just 1. And then the 3i plus I, remember it's like a 1i. So we can take the 3 plus 1 in a bracket, take the I in front or behind, and we really get 1 plus 4i. For the beginning part of complex numbers, so we're combining a little bit from 16A, which is all about the arithmetic, and 16C, which is about sketching. So make sure you have some detailed notes about the complex numbers, and then go ahead and complete the exercise. And this is the only time when you're allowed to have an imaginary friend, known as I.